This lesson is on circles and line segments. So we're going to start by talking about some basic circle terminology. The radius of a circle extends from the center to a point on the circle. The diameter of a circle extends all the way across. The diameter is also known as a chord. A chord is a point that touches the circle on its endpoints are on the circle itself. So that would be a chord. The longest possible chord on any circle would be its diameter. A secant is a line that goes through the circle in two places. So it intersects the circle in 2 points, or at 2 points. And a tangent just touches the circle at 1 point. So here we have our radius. Here we have our secant, our tangent, and that would be a chord. So there's our basic circle terminology. So we want to look at some relationships between chords in this particular circle. So we're gonna call this 10. That's going to be 5. I'm going to call this not drawn to scale, but that's okay, 25, and we're going to call that 2. So if we were doing this as an investigation in class, I would have you measure these segments here. So I would have you measure this to see that that's 10. I'd have you measure this segment to see that that's 5. I'd have you measure this segment to see that that's 25, and this segment to see that that's 2, and then ask you to look for a relationship between this pair of chords within this circle. So if you notice, 5 times 10 is equal to 50. 2 times 25 is also equal to 50. And that's not just a coincidence. When you have 2 chords that intersect one another, the product of each of the segments for each chord, the products are equivalent to one another. So if we called this little piece A, B, C, D, we can say that AB is equal to C times D. So this segment times this segment is equal to this segment times this segment. Well, what can we do with that information? Well, if you know, say for instance, that this side is 8, and this side is 5, or this segment is 8, this segment is 5, this segment is X, and this segment is 10, using this information, we can determine what this value of X actually is. So we know that we multiply the 2 segment pieces that are on the same chord together, so 40 is equal to 10 times X. And then we can solve the equation for X. We divide both sides by 10, so X equals 4. All right, so now we have 2 secants of a circle intersecting outside the circle. So just like when we had 2 chords intersecting, we noticed a relationship. There's also a relationship when we have 2 secants intersecting outside of a circle. This segment here, which I'm going to go ahead and just label each of these. This is segment AB. We're going to call this C. We'll call this D. And we'll call this E. So the relationship that happens here, the product of segment AB times AC, segment AC, which means the entire segment. So now we're looking at this little piece multiplied by the entire piece. So segment AB multiplied by segment AC. That's equivalent to segment AD times AE. So AD times AE. So if this is 2 and this is 5, this piece, the product of AB times AC would be 2. And here's a common misconception. It's very tempting to multiply it by 5, but our equation here has us multiplying by AC, which is actually 7. So that's equivalent to 14. So if this piece is 3, so we know 14 is equal to 3, so AD is 3. We could figure out the value of AE, this entire segment, that's going to make that statement true. So I would divide both sides by 3. So AE would be equivalent to 14 over 3, which is roughly, let's see, 4 point, let's go ahead and do that out. 3 into 14 goes 4 times 12, remainder of 2. So 4 2/3. So 4.67. So that means this whole piece is equal to 4.67, which means DE would be equal to 1.67. Okay, let's look at another one of those. Yes, I could have made my eraser a little bit bigger. There we go. Okay, so again, let's look at this relationship. Segment AB times segment AC is equivalent to segment AD times segment AE. So if this is 5, and this is 6, and this is 3, and I said let's find segment DE. So that's this piece right here. Well, with our equation here, we have the product of AD times AE. So if we go ahead and find AE, we can use that information to help us find DE. So AB is 5 times AC. Again, it's so tempting to multiply by 6, but you have to multiply by AC, which is 11. And that's equal to AD 3 times AE. So that gives us 55 is equal to 3 times AE, segment AE, sorry. Divide both sides by 3. 3 goes into 55. 8, 24, 18 and 1/3 times, or 18.33. So this entire piece is 18.33, which makes this piece 15.33. I just subtracted 3 to determine this side here.